Welcome back to the Neural Intel Pod. Ready to dive into some serious fine-tuning today? We're talking large language models and how we can mold these AI behemoths to our will with the help of Unsloth.
It's amazing what you can do, really. You take a model already trained on just mountains of data, and then you can shape it even further, make it even better for a specific job.
It's like taking a Swiss Army knife, right?
Yeah.
And instead of just using the basic blade, you sharpen one to become a scalpel. So you're
Yeah.
taking this multi-tool and making it hyper-focused.
Exactly. It already has all that base knowledge, all those core skills, but now it becomes a true specialist, an expert in one particular field.
And that's where fine-tuning really comes into play, right? Instead of
Yeah.
starting from scratch, you're taking this already brilliant student, so to speak, and you're giving them specialized knowledge.
Right. It's much more efficient than building a model from the ground up, for sure. You get to tap into the incredible power of these pre-trained models, all those complex language patterns they've already learned.
So let's say you're building a medical chatbot. You wouldn't start with a blank slate, would you?
No way. You'd grab an existing powerful LLM, something that's already got a good grasp of language, and then you'd fine-tune it on all things medical. Textbooks, research papers, clinical guidelines, the whole shebang.
You're basically giving it a medical degree. So what are some real-world examples of this fine-tuning magic, things people might already be using?
Oh, well, ChatGPT is a great example. That's a fine-tuned version of GPT-4, but it's been specifically honed to follow instructions and have a natural back and forth like you'd have with a person.
So OpenAI basically took GPT-4 and was like, all right, now learn to be a chatbot and a really good one at that.
Exactly. It can write you a poem, explain some crazy scientific concept, even crack a joke or two, all thanks to fine-tuning.
Impressive. Any other cool examples?
Oh, absolutely. There's one called DeepSeek R1 Distill Llama 8B. Kind of a mouthful, I know. But the cool part is they took the reasoning power of this model, DeepSeek R1, and they essentially distilled it into Llama 3.18B.
So they took the brain power of one model and infused it into another. That's wild.
It is. They created a hybrid, a sort of super-powered llama, if you will, with enhanced reasoning capabilities.
So it's like we're giving these models specialized education, honing their skills for specific tasks. But why go through all this trouble? What are the benefits?
Well, for starters, think about it this way. Those pre-trained models, they're trained on a snapshot of data, right? A moment in time. Fine-tuning lets you update that knowledge.
So you can keep them fresh, so to speak, keep them up to date with the latest info.
Exactly. And it's not just about adding new facts. You can fine-tune a model to change its style, its tone. Do you want a chatbot that's super friendly and casual, or one that's a bit more formal and buttoned up?
You can mold its personality.
Yeah.
It's like creating a whole cast of AI characters, each with its own voice and quirks. But beyond personality and knowledge updates, are there other advantages to fine-tuning?
Absolutely. One of the biggest is task optimization. If you need a model to be amazing at one specific task, fine-tuning is the way to go. Let's say you want to build a model that writes code and writes it really well.
You wouldn't just feed it a bunch of random text, would you?
Nope. You'd fine-tune it on a massive data set of code, give it a deep dive into the world of programming. Then it would become way more efficient and accurate than a general-purpose model.
You're basically turning it into a coding prodigy. Makes sense.
Now let's get into the nitty-gritty. How do we actually do this fine-tuning? What are the tools involved?
Well, there's a fantastic tool called Unsloth that's really been making waves. It's powerful, but also surprisingly user-friendly, even if you're not a coding wizard.
So Unsloth is like the easy bake oven of fine-tuning.
You could say that. It simplifies the whole process, makes it more accessible to a wider range of users.
Okay, but what's going on under the hood? What are the actual techniques involved?
Unsloth uses these clever techniques called LoRA and QLoRA, which are designed to make fine-tuning more efficient and less resource-intensive. LoRA and QLoRA. They sound like something out of a sci-fi movie. What are they and what makes them so special?
LoRA stands for low-rank adaptation. It's all about fine-tuning specific parts of the model instead of trying to update everything at once.
So it's more like making targeted adjustments, right? Instead of overhauling the entire engine.
Exactly. Now, QLoRA takes things a step further. It combines LoRA with something called 4-bit quantization.
Quantization. That sounds a bit intimidating.
It's basically a way to compress the model's data, make it smaller, without losing too much accuracy. And the really cool thing is this allows you to fine-tune these massive models even if you don't have a supercomputer.
So even with limited resources, I could potentially fine-tune a large language model.
Absolutely. You could do it on platforms like Google Colab or Kaggle, or even on your own computer. You don't need a huge server farm anymore.
That's pretty incredible. It really opens up the possibilities for who can get involved in this field. But I have to ask, does this compression, this quantization, does it compromise the model's accuracy?
It's a valid concern. Traditionally, quantization techniques did result in some accuracy loss. But Unsloth does things a bit differently. It uses something called dynamic 4-bit quants.
Dynamic 4-bit quants. Okay, now you're just showing off.
Haha. Well, what these dynamic quants do is they minimize the accuracy loss. So in many cases, QLoRA is almost as accurate as LoRA.
So you're getting the best of both worlds, efficiency and accuracy. But we can't forget about the data itself. It's not just about the tools, right?
The data is absolutely crucial. It's the fuel that powers the entire fine-tuning engine. You can have the most sophisticated tools in the world, but if your data is garbage, well, you know the rest.
Garbage in, garbage out. It's a classic for a reason.
And there are different ways to go about building your data set. You can actually use LLMs, like ChatGPT, to generate synthetic data.
Wait, so you're using one AI to create training data for another AI? That's pretty meta.
It is, right. But it can be super helpful, especially if you're working with a very niche topic or a language where there isn't a lot of data available. It's a great way to get a large volume of data quickly.
So you're essentially bootstrapping the process. But wouldn't you want some real-world data in there too?
Absolutely. Synthetic data alone might not be enough. You might want to curate real-world data into a format that's suitable for fine-tuning. For Unsloth, that typically means structuring your data as question-answer pairs.
Why question-answer pairs specifically? Is there something special about that format?
It's all about mimicking conversation. Those question-answer pairs, they're like a back-and-forth dialogue. You're teaching the model how to respond in a relevant and coherent way.
You're not just stuffing it with info. You're teaching it how to use that info in a conversational context.
Exactly. But I will say sometimes, depending on what you're aiming for, just giving the model a huge amount of relevant data, even without strict formatting, can work really well.
Yeah.
Like if you're fine-tuning for code generation, just feeding it tons of code can lead to some impressive improvements.
It's like immersion learning for AI. So we've got the tools, we've got the data, we're ready to start fine-tuning. But how do we actually control the process? How do we make sure it's heading in the right direction?
That's where things get really interesting. We enter the world of hyperparameters.
Hyperparameters. Sounds a bit intimidating.
Think of them as the settings that control how the model learns. They influence things like how quickly the model adjusts its understanding and how many times it revisits the data during training.
Okay, so they're like the instructions you give the chef, right? The ingredients are the data, but the hyperparameters determine how those ingredients are combined and cooked.
Perfect analogy. And there are tons of different hyperparameters you can tweak, just like there are endless ways to bake a cake. But some of the most important ones are the learning rate and the number of epochs.
Learning rate and epochs. All right, break those down for me.
The learning rate basically determines how much the model adjusts itself with each step of training. Imagine you're learning to play a new instrument. A high learning rate would be like trying to learn a whole song in one go.
You might progress quickly, but you'd probably make a lot of mistakes along the way.
Exactly. A lower learning rate would be like practicing one note at a time. Slower, but you build a stronger foundation.
And what about epochs? What do they represent in this musical analogy?
Epochs refer to how many times the model goes through the entire training dataset. It's like the number of times you practice that whole song from beginning to end. The more you practice, the better you get, but you also risk overplaying it and losing some of the nuance.
So more epochs generally lead to better learning, but there's a point where it can become counterproductive.
You got it. It's about finding that sweet spot. Too few epochs, the model might not learn enough. Too many, and it might start to memorize the data instead of understanding the patterns.
It's like learning a song by heart, but not understanding the musical theory behind it.
Exactly. You can play it perfectly, but you can't improvise or apply those skills to other songs. That's what we call overfitting in machine learning.
So we need to find the right balance between practice and theory, so to speak, to create a model that's both accurate and adaptable.
Precisely. And once we've got our data prepped and our hyperparameters set, we're ready to hit that train button.
But how do we know if things are going well? What should we be looking for during this training process?
That's where training loss comes in. It's a metric that tells you how well the model is learning. Generally, you want to see that training loss decrease over time, which means the model is making fewer errors.
So a lower training loss is a good thing, like getting a lower score in golf.
Exactly. But it's not just about getting the lowest score possible. You also need to keep an eye out for that overfitting we talked about. That can happen even if the loss is decreasing.
So how do we know if the model's overfitting? What are the red flags?
One big sign is if the training loss is going down, but the model performs poorly on a separate set of data that it hasn't seen before. It means it's memorized the training data instead of really understanding it.
It's like acing the practice test, but bombing the real exam.
That's it. It's all about finding the right balance between minimizing that training loss and making sure the model can actually generalize, apply what it's learned to new situations.
Sounds like a delicate balancing act. So how do we actually evaluate the model once it's been fine-tuned? How do we know if it's truly successful?
Well, there are a few different ways to go about it. One option is to simply interact with the model, have a conversation with it, and see how it does in a real-world setting.
So just chat with it and see how it responds. Sounds like a fun way to evaluate a model.
It is. It gives you a qualitative sense of its capabilities, but you can also be more quantitative about it. You can set aside a portion of your data specifically for testing.
So you're holding back some of the data during training
Hmm.
and then using it as a final exam to see how well it performs on fresh examples.
That's the idea. And there are some automated tools out there too, like Eleuther AI's LLM evaluation harness. This can give you more comprehensive metrics, and you can even compare different models or different fine-tuning techniques.
It's like having a judging panel for a baking competition.
Hmm.
You might have objective criteria like taste and texture, but ultimately, the best cake is the one that pleases the judges' palates.
Exactly. Evaluation is about figuring out if the model meets your specific needs and preferences.
This has been a fascinating journey so far. We've covered the what, the why, and the how of fine-tuning. We talked about the tools, the techniques, the importance of good data. But before we wrap up this part of our deep dive, I have one more question. Once we've trained our model, how do we actually use it? How do we bring it to life and start generating text or having conversations?
That's where the magic of inference comes in. Inference is all about using that trained model to make predictions on new, unseen data. It's like taking your finely tuned instrument and finally playing a new song.
I'm intrigued. Let's delve into this world of inference in the next part of our deep dive.
It really is amazing when you think about it. You take this model that's been trained on just mountains of data, and then you can use it to generate some creative text or answer your questions in a snap.
Okay, you've definitely piqued my curiosity here. Walk me through this inference thing. It sounds like we're finally taking our trained model out for a spin, letting it loose in the real world.
Yeah, that's a great way to think about it. Inference is all about actually using the model to make predictions on new data it hasn't encountered before. Think of it like the performance after all those rehearsals.
So we've put in all this work training the model, teaching it everything we can about language, and now it's time to shine.
Exactly. And Unsloth makes this whole process really smooth. You can just load your fine-tuned model and start interacting with it right away. You give it a prompt, maybe the beginning of a story, and you see what it comes up with. Or you can have a back and forth, like a conversation. You ask it questions and see how it responds.
Speaking of conversations, let's say I'm having a multi-turn conversation with this model. Can I remind it what we talked about before? How do we make sure it remembers the context, stays on topic?
That's where context management comes in. You can feed the model information about the previous turns in the conversation, give it that background so it can generate more relevant responses. It's like giving it a cheat sheet so it doesn't lose track of what's been said.
So it's like whispering in the model's ear, hey, remember that thing we were just discussing? Keep that in mind.
Exactly. And the great thing is, Unsloth handles all that behind the scenes. You don't need to worry about the technical stuff. Just focus on having a natural conversation. Let Unsloth take care of the rest.
That's reassuring. Now, you mentioned that Unsloth has really fast inference capabilities. Why is speed so important, especially when we're dealing with these huge language models?
Speed is key for a good user experience, for sure. Imagine you're chatting with a chatbot and it takes forever to respond. It would be so frustrating, right? Unsloth is optimized to generate those responses quickly, even with complex prompts or multi-turn conversations. It keeps things flowing smoothly.
So it's like having a conversation with someone who's quick on their feet.
Yeah,
They can keep up and respond in a timely manner.
exactly. And this speed is super important for real-time applications, things like interactive storytelling or game development, where you need those responses to be snappy.
Makes sense. Now let's talk about controlling the output a bit. Sometimes you want a short and sweet answer. Other times you might need a more detailed explanation. Is there a way to adjust how much the model actually says?
Absolutely. You can control the length of the model's output using a parameter called max new tokens. Tokens are essentially the building blocks of text. They can represent words, punctuation, or even parts of words.
So if I want a concise answer, I would set a lower limit on those tokens.
Exactly. If you're building a chatbot that needs to give quick, factual answers, you might set max new tokens to a smaller value. But if you're generating longer pieces of text, like a poem or a story, you'd give it more room to work with.
It's like setting a word limit for an essay. Sometimes you need to be concise, sometimes you can elaborate more. Now, let's say we've fine-tuned our model and we're really happy with how it's performing. How do we share it with others? Can we package it up and send it out into the world?
Definitely. One of the coolest things about Unsloth is how easy it makes sharing your fine-tuned models. You can save your model as a LoRA adapter. That's a small file that captures all the changes you made during fine-tuning.
LoRA, right. That's that technique that lets us make targeted adjustments to the model instead of overhauling everything.
That's it. And these LoRA adapters are surprisingly small, usually around 100 megabytes. Super easy to share.
That's pretty incredible. Considering how much knowledge these models have, it's like compressing an entire library into a single book.
It is, kind of. And anyone with Unsloth can use these LoRA adapters. They don't have to go through the whole fine-tuning process themselves. They can just plug in your adapter and use your customized model.
So it's like sharing a recipe. They don't have to start from scratch. They can just follow your instructions and recreate the same delicious dish.
I like that analogy. And to make sharing even smoother, Unsloth works really well with a Hugging Face Hub.
The Hugging Face Hub. Remind me what that is again.
It's basically a popular online platform where people can share and download machine learning models. LoRA adapters included. You can upload your model to the hub with just a few lines of code, making it accessible to anyone.
So it's like a giant library for AI models where people can browse and borrow different models depending on what they need.
Exactly. It's a fantastic resource for discovering new models, learning from others, and contributing to the AI community as a whole. You can find models for everything from translating languages to creating images to composing music.
Sounds like an AI enthusiast's dream. We've covered a lot of ground in this episode. We explored the intricacies of fine-tuning, we delved into the world of inference, and we even talked about sharing our creations with others. Before we wrap up, any final words of wisdom for our listeners as they set off on their own fine-tuning adventures?
One thing to keep in mind is that fine-tuning is a journey. It's an iterative process. There's a lot of experimenting, observing, and refining involved. Don't be afraid to try different things, tweak those parameters, and see what works best for you. There's no one-size-fits-all solution in AI.
So it's like any creative endeavor. You need to experiment, be persistent, and embrace that learning curve.
Absolutely. And remember, there's a huge community of people out there who are passionate about AI and are always willing to help. Don't hesitate to reach out, ask questions, learn from others. The AI world is constantly evolving, and the best way to keep up is to collaborate and share knowledge.
That's great advice. All right, let's move on to the final part of our deep dive, where we'll tie everything together and leave our listeners with some food for thought. Okay, so we've made it to the final act of our Unsloth fine-tuning saga. We've explored the what, the why, and the how. We talked tools, techniques, and all-important data. But now, let's zoom out a bit. Big picture time. What are the key takeaways you really want our listeners to walk away with?
I think the most exciting thing is how accessible fine-tuning has become. Tools like Unsloth, they're putting this incredible power to customize these AI models right into the hands of individual smaller teams. Something that used to be only for the huge companies with tons of resources. It's really democratizing AI development.
So it's not just the Googles and OpenAIs of the world playing in this sandbox anymore. Anyone with a bit of technical know-how and the right tools can create their own specialized AI.
Exactly. And that opens up so many possibilities. Think about it. Personalized learning experiences for students, hyper-targeted marketing content, even AI assistants for researchers in very specific scientific fields. It's pretty much endless, the things you can do.
It's like having a whole team of superpowered AI assistants, each one perfectly fine-tuned for a specific task. But before we get too carried away with the possibilities, let's bring it back down to earth for a second. What are some common challenges or pitfalls that people might run into when they're fine-tuning, and how can they avoid those?
The data hurdle is still a big one. Like we talked about earlier, the quality of your training data, how relevant it is, that's really the most important thing. If you feed the model bad data, you'll get bad results no matter how well you fine-tune it.
Garbage in, garbage out, right?
Exactly. So spend the time to really curate that data set, clean it up, make sure it aligns with what you're trying to achieve. And remember, Unsloth loves question-answer pairs. So structure your data that way for the best results.
Good data hygiene is key for a healthy AI, it seems. What about overfitting? We talked about that before, but it sounds like it's a constant battle in the machine learning world. Any tips on how to prevent our models from getting too specialized, too focused on the training data, and losing their ability to generalize?
Overfitting is definitely something to watch out for, especially when you're dealing with smaller data sets. One good technique is to start with a pre-trained model that already has a strong understanding of language. That gives it a good foundation and makes it less likely to get hung up on the little quirks of your training data.
So you're giving it a bit of a head start so it doesn't have to learn everything from scratch.
Yeah, exactly. And Unsloth actually has some built-in tools to help with this too, like early stopping and dropout. These help regulate how the model learns, kind of like giving it regular breaks so it doesn't cram too much information at once.
Sounds like some pretty handy tools to have in your fine-tuning toolkit. Well, before we wrap up completely, any final words of advice, a parting thought you want to leave our listeners with?
You know, the thing that really inspires me about fine-tuning is that it embodies this idea of constant learning, always improving. So don't be afraid to experiment, to iterate, to really push the boundaries of what you can do with these amazing AI models. The more we explore and refine these techniques, the more we unlock the potential to solve problems, to create new possibilities, and honestly, to just make our lives a little easier and a lot more interesting.
That's a fantastic note to end on. Thanks for joining us on this deep dive into the world of fine-tuning with Unsloth. We hope you're feeling energized and ready to embark on your own AI adventures. And remember, if you want to learn more about Unsloth and all sorts of cutting-edge AI and ML research, check out the link in our bio to our webpage.
It's been a pleasure diving deep with you.
Keep those neurons firing, and we'll catch you in the next episode of the Neural Intel Pod.